Okay, problem number 5. Graphically determine the resultant of the following 3 vector displacements. Resultant means our total sum of these displacements. So I do this lesson a little differently with my STEM physics students because we don't do vectors necessarily. And what we can imagine is that these are displacement vectors of a pirate ship traveling around, or traversing a jungle, or, surviving a dungeon, etc. So we want to figure out what the total displacement is, and we're going to do that graphically. So the first thing that we have is we've got these 3 vectors. They give us a length here for each one. They give us a direction, and understanding the direction is perhaps the trickiest part. Welcome to your traditional compass rose, right? North, south, east, west. I always draw it on my problems. So there's my compass rose. So when this first vector tells me that it's pointing north of east, what it's saying is if I were facing east, I'm going 25 degrees north. So this... Oh, perfect, Sage. So this is going to be a vector going that-ish direction, except this angle right here is going to be 25 degrees, and the length of it will be 34 meters. We'll measure that out in a second. This one, 33 degrees, east of north. So they're saying if I'm looking north and I turn east, then I'm measuring this angle right here. Why would they do that to you? Just to force you to practice looking at things from different angles. And then the next one says 22 meters, 56 degrees west of south. So that means looking south, turn west. And so this one is going to be a vector pointing this way with a 56 degree angle in that direction. So this is just like other language you're more used to using, like saying that something is left of the gas station. That means look at the gas station, and now look left. So if this said left of the gas station, think about what action you would perform to say, where am I supposed to be looking? You'd say, well, I'm going to look at the gas station first. That's my target. That's like the second cardinal direction here. And then say, ooh, now I'm going to turn towards the left. So I'm going to turn towards the north from this location. All right. So the gas station is like east, left is like the north. Okay, we're going to draw each of these vectors. I'm going to do that. The first one is vector A in purple. The next one is vector B in pink. And the third one is vector C in green. And then we'll figure out the resultant of those. In order to make things work on a piece of paper, I'm going to create a scale, and the goal is that scale will allow me to draw these actually with an appropriate length. I'm going to say that 1 centimeter on my, that 1 centimeter on my graph paper here is equal to 10 meters in real life. So this is 3 centimeters. I'm going to say that's equal to 30 centimeters in real life. So your graph paper, or the graph paper I'm using is on a centimeter grid, but you could do this on a piece of notebook paper really carefully as well, because I'm just going to be using my ruler on my protractor or another ruler to do the same measurement. So every centimeter I go, I'm going to say is equal to 10 meters in real life. Okay. So first I'm going to draw vector A. I'm going to start way down here in the bottom corner, or middle-ish, because I know that I've got vectors that are going to go vaguely that way, and then back this way. So first thing I'm going to do is just pick a point to start. I'm going to start right here. That's my favorite spot. I've decided that's the beginning of vector A, so it's going to be the tail end of vector A. And now I need to figure out my angle. My rule of thumb when I am trying to measure things with angles is make a mess. So I'm measuring 25 degrees north of east. That means look eastward and then turn yourself north 25 degrees. So there's my 25 degree mark, right? Somewhere along this line, I'm going to be walking in this direction, hunting for buried treasure, and then I'm going to stop at some point and turn and change direction for vector B. So how far am I going to go? 34 meters. So on the scale that I've invented, that should be 3.4 centimeters, conveniently right there. So I'm going to measure and draw. There's my vector. So what did I do? From this right here, this is 25 degrees north of east. That's how I measured my angle. And the length of this is 34 meters, because 34 meters is 3.4 centimeters on my scale. So now, starting at the tip of vector A, I'm going to draw the tail of vector B. Right, so vector B is starting at this place right here, and they're going 33 degrees east of north. So I'm going to stand around in my jungle looking for my buried treasure. I'm going to turn to the north, and then I'm going to look 33 degrees. Wait, I should read my directions. East of north. Oh my goodness. Paying attention, see? 33 degrees. I'm going to look towards the north, and then turn 33 degrees this way. So there's 33. So this is my line of sight here. This is the direction, 33 degrees east of north. So just to sort of show, how did I do that? Where's my angles? This angle right here is 33 degrees east of north. And now I'm going to walk off in the jungle in that direction. How far? 48 meters, which on the scale that I picked is 4.8 centimeters. So I'm going to go a long way past the jaguar-infested pits in the jungle looking for my buried treasure. And that's vector B. It's 4.8 centimeters long, because on my scale that's equal to 48 meters. And that's vector B. Okay. My last vector, vector C, tracks backwards. It's going to go over the top of some of my writing, which is the joy of a video, right? So now vector C is going to start from this point. It's going to go 22 meters, 56 degrees west of south. So to figure out my direction first, I'm going to line up my protractor where I'm looking south. I see that there's the giant bat-filled caves, and I'm wondering, is the treasure over there? And I'm going to look, how many degrees? 56 degrees all the way over here towards the west of south. So this is my line of sight, and now I'm going to march off through the jungle, sure to find the buried treasure. So again, how did I measure this angle? I looked in the southward direction here. This angle right here was, and it's hard for me to write in there, right? Was 56 degrees west of south. Now how far am I going to go? It says 22 meters, which on my scale is 2.2, boop, right there, centimeters. So I went 2.2 centimeters, because that equals 22 meters, and that's my vector C. So I've got a pretty messy piece of paper, but now we're ready to figure out our resultant vector, because that is going to be from the tip to the tail of, or from the, we'll draw our total vector here. We've added these together, tip to tail essentially, and now I can draw what the resultant is. Where did I start? My initial position is right here. Where's my final position? Right here. That's where I ended up. That's where the buried treasure was, but I had to go around the jaguar pits, the battlefield caves, etc. So this right here is my resultant vector. So if I want to know if instead of having to traipse around the jungle following some treasure map that, wasn't good enough for a Pirates of the Caribbean movie, how could I get there by flying broomstick using, Harry Potter magic instead? Well, let's figure out how far I would need to go. So I'm using my same scale on my ruler and measuring that this looks like 5.7-ish centimeters, 5.7 centimeters. And on my scale, that means 57 meters. And now I need to give a direction to this vector. I like keeping things simple, so I'm going to start with my protractor lined up the way I like. And I'm going to measure this angle. Ooh, that is like almost spot on 50 degrees. 50 degrees. And now I need to describe that direction using my compass rose. Well, where did I start? I looked east, and then I turned towards the north. So that was north of east. So that is my resulting vector. So that's how you can graphically add vectors together. All you need to do that is protractor, some care, a ruler, and the ability to not lose your head in the middle of a jungle while searching for buried treasure. So that was number 5 from chapter 3 on page 65 of the problems.